Hi everyone, so today I'm going to be going over the classwork from May 26th. It's kind of our introduction to similarity for similar shapes, similar polygons. So what I'm going to do is I'm going to actually review maybe one or two of these, and then I'm going to do a problem that's a little bit tougher with the algebra. So let me start with just number one here. Again, what similarity means is that means it's the same shape, but like a different size usually. So for this one, like your sides, that would be proportional, your corresponding sides. So for instance, I'm going to do, let's see. The corresponding side of rectangular shape is pretty easy. This 10 is corresponding to the 15. I like those in blue. And then, then the question mark here is corresponding to the 24. Okay. So once you have that, the next step I want to show you guys is just to set it up like a proportion. Like you guys learned last week how to do this math. I'm going to switch to a more visible color. Okay, purple. So we're going to set a proportion, and basically I want you to use the colors. So I'm going to say that 10 over 15, actually. I'm going to go to, I'll set it up. Let's do teal first. So 10 over 15. This is a 10 here. It looks kind of like a 6. So 10 over 15 is going to be equal to, that ratio will be equal to the question mark. I'm going to call that x. So I'm going to call this x over here. It's equal to x over 24. And once you have that proportion, the actual math you do is going to be pretty straightforward. We're just going to cross multiply. So let's see, let's do multiply this across. So 10 times 24 will be equal to 15 times x. So 10 times 24 will be equal to 15 times x. So what's 10 times 24? That's 240 is equal to 15x. Then to get x by itself, we just divide both sides by 15. So divide this side by 15. So this cancels. And then you divide this side by 15. So what's 240 divided by 15? Well, 60 divided by 15 is 4, so must be 16. So x will equal 16. 240 divided by 15 is 16. So let's see. Next step, let's look at number 2, just to put a little bit into perspective a bit more. So let me grab a screenshot of that. So I'll do 1 and 2, and then I'll do one of the algebra problems as well. So let's see. We know that here the 12 and the 15 are the corresponding sides. I'm going to highlight this. These two sides are corresponding. And then the other sides are corresponding. We're trying to figure out what this question mark would be. So let's see. We'll use the blue. So this, I'll call it x. So this question mark, that's not very good. Let me try that again. this side is corresponding to this side. X is corresponding to 25. So now we just got to set up our proportion. So we know that x over 25 that ratio has to be equal to the ratio between 12 and 15. You have to be careful. It has to be x to 25. So this shape to this shape, this side to this side. You have to make sure you go in the same order. So 12 over 15. Okay. So for this, let's cross multiply here. So x times 15 will end up equaling 12 times 25. So x times 15, so 15x will equal 12 times 25. Okay, so 15x, what's 12 times 25? Let's see. That must be 300. If you have 12 quarters, you'll have $3. Then we just got to divide both sides by 15. So it cancels over here. So x will be I can't do that in my head, so I'm actually going to need to do the long division over here. How many times is 15 going? 15 can't go into 3, but 15 goes into 30 twice. 2 times 15 is 30. Subtract, that's 0. 0, how many times is 15 going to 0? That's 0 times. So the answer is 20. So x is equal to 20. So this side right here must be 20. Okay, so I just did two of the, I think, problems that don't involve as much algebra, more just straight up proportion problems. So let's do one that has a bit more of an algebraic expression in it. So I just did 1 and 2. I want you guys to do 3, 4, 5, and 6. And now I'm going to do 17 here, and you're going to have to do 18. All right. Okay, so again, important thing is let's find our corresponding sides. So the longest side here looks like it's the 49, so I'm going to highlight that in purple. Would match this side over here. And you know, these aren't the same lengths, they're just proportional. Like, these are definitely different size shapes. Now let's try, I think the next biggest, actually, no, I think I did this wrong. This 49 here, I think it matches up with the 42. Let's try that again. Let's, the longest side there is definitely the 63. So I missaw that. So let's try that again. This 49 matches this 42. Okay, now that 63, I think, matches the other one. So let's try green. 63 will match this side here, 6x minus 6. And then let's do one more color. Let's do it in blue. This 35 will match this over here. So I've kind of matched up all the sides that are proportional. The one we definitely need to use, we're trying to find out x, so we have to use that proportion. We have to use the green ones. So let's use green. Okay, so I'm going to set up a proportion first. We're just going to say that's 6x minus 6 over 63. It's got to be equal to something. So we could actually use blue or purple. We started with 6x minus 6, so we could say it's equal to 30 over 35, or we could say it's equal to 42 over 49. Doesn't really matter. I'm going to use 30 over 35, because I think those numbers just look a little bit easier. But it doesn't matter. You could use the purple ones instead. So 30 over 35. Okay. So now we just have to cross multiply. Okay. So basically what we have now we'll use a navy, okay. So we have 35 times 6x minus 6 must be equal to, I'll make this a little bit wider, 30 times 63. So this looks a lot more complicated, but like I'm going through the exact same process I did before. Now I just have to solve a little bit of a harder algebra problem. Okay, so over here, we have to distribute the 35 to both these things, to the 6x and the 6. So let's figure out what 35 times 6 is. And I'm actually, let's see, okay, here we go. Let's see, okay, this is our, we can use this calculator. So once you pull out your phone, you have something like this. 35 times 6 equals 210. So let's see. So right here we have 210 x minus 210. And what's 30 times 63? Let's figure out what that is. 30 times 63 equals 1,890. Let's see, where was I? Right here. Okay. 1,890. Okay. So next step, I'm going to, so I'm trying to get x by itself. Let's get rid of this minus 210. So what I'm going to do is I'm going to add 210 to both sides. Add 210. So that's 0. Well, it's not custom pen. This is 0. That's 10. So let's go up carry. This is 11. Okay, so 2,100. Okay, so when I set this up, this cancels. So we should have 210x 210x equals 2,100. So I'm going to copy that down over here. 210x equals 2,100. So we just got to divide both sides by 210. So these cancel, you get left with an x. So x will be equal to, what's 2,100 divided by 210? That'll just give you 10. So basically, 10 is x. If I were to plug that into here, we get 6 times 10 minus 6. So 6 times 10 is 60, minus 6 is 54. So this side over here is actually 54. All I did was plug into that equation. But you didn't actually define it. You just defined out what x was. So that's the goal of this. So what I want you guys to do is I want you guys to figure out what